Bismillahirrahmanirrahim. My name is Dr. Furqan. Today I am going to discuss some of the important common statistical tests. Basically, there are four tests we use in statistics. Number one is the t-test, second is the ANOVA, the third is the chi-square, and the fourth is the Fisher-Exact test, right? In the first one and two, basically we compare the means of a value in this test, right? In the third and fourth, we categorize these four tests into two categories in the chi-square and Fisher-Exact test. Basically, we compare the categories or proportion of variables, right? So, if the t-test is used in the, we take two groups, right? If the data is having two groups, then we use the t-test in the statistics. Just like, for example, if we take men versus women and we compare their blood pressure, right? So if we take one man and his BP blood pressure is 110/70, in a woman we compare that the blood pressure comes out to 120/80. So we compare basically these two groups. Like the men, we took the 50 men, the blood pressure came out, the mean blood pressure came out to be 110/70 at the age of over 50. And when we took a woman of 50 year of age at 50 sample size, the mean blood pressure was 120/80. So if we compare these two and we think that the woman has got high blood pressure slightly, mean average blood pressure was slightly high, then by studying these, we can compare it by using the t-test. Basically, in t-test, we only compare two groups, right? Then ANOVA. In ANOVA is the analysis of variability, right? So basically, this test is also used for comparison of the means in a data, but it is used for three groups or more than three groups, right? Like we can make it more than three groups. Like just like we can say that variability can be used in different three ethnic groups. Just like if here we took the means of men and women, but if we take 50 Asian, 50 Europeans, right, and 50 Africans, and we compare the blood pressure, the average blood pressure in Asian was just like at the age of 50 was 130/80, right? But in 50 Europeans, they have slight increased obesity tendency, so they have a bit high blood pressure, and their 50 European men or women have got a blood pressure of 140/90. But in Africa, they have a lean body weight is lower as compared to the Asian and European, and we saw that the 50 men average was 120/75. So we saw that if we compare these three groups, means of these three groups, we use the test is ANOVA, right? It is very simple. So now we use the chi-square and the Fisher-Exact test. So we use the chi-square when we are given the proportion of data. Proportion can be a nominal data, and it can be ordinal data, right? What is a nominal data? Nominal data is something which cannot be numbered, like just so we can say a color like green. It is just a color, cannot be numbered, right? And we can take another example, just like another thing in ordinal. We can say that it gives us order, like more likely, likely, less likely. So it gives us the order. So such sort of data we compare by checking the chi-square test and Fisher-Exact test. If the sample size is large, then we use the chi-square test in that category. And if the sample size is small, then we take the Fisher-Exact test, right? The sample size of the population taken is small, then we use the Fisher-Exact test in that category, right? So in t-test and ANOVA we take the means. But in chi-square and Fisher exact test, we take the proportions, right? And proportions are the categories. So category of the data can be nominal, it can be ordinal, right? So if we take such sort of data, we use the chi-square or Fisher exact test. Thank you so much. So in chi-square test, basically we measure the compare the proportions of different groups or percentages, right? I forgot to say, but we measure the compare the percentages of two groups as well, right? So basically, how can we give an example for this? Example for this, it is very simple. Just like if we take 1,000 African males, 1,000 Europeans, right? And we compare the percentage of population having the hypertension. We saw that the African people had the 10% people had got hypertension, right? At the age of 60. But in European people, we saw that there is like more tendency of obesity, so they have got the percentage of hypertension was 20% in 1,000 European people. So if we compare this group to this group, we will use the chi-square test, right? And we will see that the European people will have a high tendency of developing blood pressure in his much more percentage. So if we compare the percentages of these two groups or three groups, we will use the chi-square test. And if the sample size is less, like we take the 10 African people and 10 European peoples, having we saw that the percentage of people in this view in African was just 1 out of 10. So it is 10%. And in European people, we saw that it was 2 out of 10, and it comes out to be 20%. So if we compare this percentage with this 10 people with European with the 10 African people having comparing their hypertension at the age of 60, and the sample size is small, so we use the Fisher exact test, right? So how can we summarize this test? We can summarize this test very simply. So you can summarize this test very simply. So the summary of this test will be we shall take variable. Variable can be two categories, having numerical data, which can be known, right? And it can be ordinal data. Ordinal or nominal data, which we generally call it categorical data. Categorical data. So if the nominal data, if we made two groups, if there are two groups, we shall use t-test. If there are more than two groups, three or more than three groups, right? So we will use the t-test, and if there are more than three or more than three groups, we will use the ANOVA test. If the data is categorical in the form of ordinal, just like likely, least likely, more likely, or nominal like color, etc. So we will use if the data is large data, we will use the chi-square test. But if the data is small, just like I took 10 African people, with you compare with the 10 American or European people, so we will use the Fisher exact test. So that's all for today. Thank you so much.